Hello guys, welcome back to my channel. I am so glad that you could find time to watch my videos, and as you all know, my returning subscribers, my returning views, we have been dealing with this layout. And if you're new here, yes, this is the layout we have been dealing with. We are designing the items found in this layout using SolidWorks, and we have done so many items. You might want to go and look at the previous videos, and we are in the support hot kitchen area, the preparation area, and today we are going to be dealing with single bowl sink. And I realized we needed to do this, all this area. Let us make all these items with bodies, right, so that they may match the undercounter fridge. We have one undercounter fridge, right? And today we are going to be dealing with single bowl sink with body, right? Now, don't forget to subscribe to our channel and give this video a huge thumbs up, and you can leave a comment so that we may know how our videos are impacting your lives. Now, here is the single bowl sink with the body. The bowl is at the middle. We have the hole for the tap. We have the hole for the tap, and at this side we have a swing door, and the other side we have a swing door. The size of the sink is 1500 by 700. Remember, we are using metric system, that is millimeters. The total height of the sink is 860. All the items have a height of 860. The freestanding items, all of them have a height of 860. At the center where the bowl is, there is no door, because basically there is very little things that you can put here because of the bottle trap and all that, the connection of the waste for the water, right? So with that having been said, we have said the bowl is 500 by 400 and a depth of 300. Now, without much ado, let us get right into it. And we open our SolidWorks. I'm using SolidWorks 2019. I find it satisfying. I don't have a reason to upgrade, but should I feel like I need to upgrade, I will upgrade, right? Now let us start with the first part, which is the top. So open new file, go to part, click OK. And like I said, we are using metric system. My custom is millimeters, grams, and seconds. If you want, you can put mmg and all that. Now let us go to the top plane. If you've been following the previous sinks, this is no different. First, we do a sketch of the overall size of the sink, which is 700 by 1500. Exit the sketch. If you want, you can rename your sketch, but if you don't want, just remember that you have a sketch there of the overall size, which will help us in dimensioning the base flange. So create a new plane. You can offset it by 10 millimeter, 100 millimeter, 800 millimeter. It depends with how you feel like. To us, there is no much pain in doing 800. In the new plane, create a new sketch, and you can enlarge the scale if you want, the plane if you want. Take center rectangle, don't snap it from the origin because we are going to dimension it. It will bring itself to the desired size. From this edge to the edge of the first sketch, make sure it's 50 millimeter. Also at the front 50 millimeter, and the other side also is 50 millimeter. And at the back it's 15 millimeter because of that edge that we are going to deal with there. Now go to sheet metal and take that as your base flange, and the thickness of the material is 1.5 millimeter, stainless steel 304 1.5 millimeter thick. Click OK. Now you can hide your plane. Now go to the back and create your edge flange. All these upstands, all the items should be uniform, so this upstand we are going to keep it at 50, blind 50. Now go and create a tab on this face and go to corner rectangle. From here we are going to give it some relationships, and this other side also. Select, you can twist it a little bit so that you may see what you're doing. Select this line and the edge of the upstand and the other line, and make relationship collinear. Then select this line and this point of the first sketch and make them coincident, same as the other side. This line and this point, make them coincident and exit the sketch. Make sure you merge result. Don't want it to be an independent part, it should be merged. That is right. Now go to the front plane and feature reference geometry plane and snap it to this point here. Let's see, yeah, the plane is good. Select. Now go to plane 2 and create a new sketch and select line from this point here. Create a line at an angle. The other one should be parallel to the face of the top, then a vertical line and an horizontal line. Let us give it a quick dimension. This should be 20 millimeter by size, and the angle here is 120 or 160, I think, because we need it to be 30. 160, yeah, that is good. And this should be 50 millimeter. As for the rest, we are going to create relationship. That line and this point should be coincident, and yes, I think that is okay. This, we forgot to dimension this and give it 15 millimeter, and that's okay. Go to sheet metal and go for the miter flange. That edge is selected automatically. Then go to this other edge, and finally this edge. There you have your top. Now go ahead and create an edge flange of 15mm. You can just leave it at that and edit the sketch. Select the face, edit that sketch, and select this line and the line of the first sketch. I'm holding the shift key to do multiple selection to make them collinear, and exit the sketch. Now you can create an edge flange. Remember, all this is done to ensure that no dot sticks there. This edge flange can be of 10mm. And our top is good. Now go ahead and hide this plane and hide also sketch 1. We don't need it. Select this face, start a new sketch, do a center rectangle. We can create relationships. This middle and the origin should be vertical. Just make sure that it is vertical. And smart dimension, this is 500, and from this edge to this point of the line, make it 65mm, and this is 400mm. 400, that's good. We are trying to create a cutout for the bowl. We can make this something like 75, that is 3 inch. You don't want the top to be too far, and again the bowl shouldn't be at the middle. Okay, create a circle, snap it from the origin. This is for the opening of the top. Smart dimension, the size. I told you most tabs have a diameter of 20, so make it 21mm. Don't want to interfere with the threads of the tab as you are inserting it. Shouldn't be very tight. This should be 60mm from the edge of the sink. That's nice. Now fillet the sketch, and at the fillet size is 30mm. All the edges, that edge, this corner, and this corner, that is okay. Now go ahead and select feature. We didn't exit the fillet. Yeah, extrude, and you can link it to thickness. You want to make the cutout completely. Yes, the opening for the top and for the bowl, that's good. Now save part number 1. Go to layout. You can create a new folder. We don't want to do that. New. And this we are going to call a single bowl sink with body. Then select the new folder and open it, and save this as part number 1 and call it single bowl sink. Top. Go to file, create new part, click OK, go to top plane, new sketch, center rectangle, snap it from the origin. We are creating the bowl now, and the bowl size is 400 by 500, feature, extrude, and direction 1, the size is 300. That's good. Now fillet the corners, and our fillet is 30mm to match with the cutout. This edge, you can select all the edges, then you select this edge, this edge, this edge. Before you shell, you must do the fillet. Otherwise, if you shell and do the fillet later, you're going to run into all sorts of troubles. Now shell and select the top face, and the size is 1.5mm, because that's the thickness of the stainless steel sheet that you're going to use. Select this face, create a new sketch, snap it from the origin, that is the center, create a hole. The diameter is around 65. Yes, 65, because we intend to use a bottle trap of 2 inch, but it's dia 50. Now this should be 60. Some of these things, if we are using a lesser machine to do your cutting, you have to confirm the dimensions. You don't want to do a big hole and you will have leakages. Extrude and cut through the bottom. There you are, your bowl is good. Go ahead and save it as part number 2, or you can call it 1A. Single bowl sink bowl. Now let us create the side panel, and we can reconfirm the dimension. The side panel will start from here all the way up to back here. That should be around 670, sorry. And the height should be 650, if I'm not wrong. We will reconfirm that as we continue. So go ahead, create new file, part, click OK. This time around, go to the right plane, new sketch, center rectangle, snap it from the origin. The size is 650, should be the height, by 670 is the length, 670. That's okay. Go to sheet metal, base flange, and now the body should not be that heavy, so use 1.2mm thick material. Now create an edge flange from the front, and this edge flange should be 50mm. 50mm, right click, and an edge flange going to the inside, which is 25mm. That's okay. And finally an edge flange here of 15 or 10mm. This depends with your machine, your bending machine. Now create an edge flange at the back, make it 100mm. Right click, and an edge flange going to the inside of 10mm. That's okay. Click OK. Now create an edge flange of 15mm at the top. There, select that edge, this and this edge also, and this edge. Make this 15mm. If you want, you can select, you can mirror that, you can exit that edge flange there and mirror it, or you can select also the bottom part and create edge flange just like you did at the top. You do what you feel like it is time saving for you, but it is always good for you new guys at SolidWorks. It's always good for you to try to master different operations, you know, how to mirror that and which plane to use for you to get the edge flange going the correct side. We might be having a problem there. There must be an overlap someplace. Yes, there's one here. Let me redelete this edge. Decided to edit. That is edge flange number 1. There should be another edge flange here which is giving us troubles. I think that was the last edge flange. Let us delete it. Yes, it is so small you can omit it. Your piece will be good. I think there is no warning now. Yes. Now, for us to get the correct size of the back plane, now we can create the top, not the top, but the undershelf. This is part number 2. SB saying side panel. We can create the bottom, the undershelf. Open new part, top plane, new sketch, center rectangle, snap it from the origin, and the size should be 700 minus 30, that is 670, by 1500 minus 30, that is 1470. I know you know why we are subtracting 30mm. How we came up with the dimensions, I'm sure you guys know because you've been following all the other drawings. If you're new, don't worry, you will see how we came up with that. Now material thickness still remains the same as 1.2. Click OK, create edge flanges all around. The 4 corners going in one direction, that is in the downwards direction. End condition, keep blind. The size is 30mm. You can do 40 if you want, but 30 is ideal. Create again an edge flange to strengthen your bottom and also avoid sharp edge and give it a nice finish. That edge flange should be 15mm. Create it all around. In the 4 corners. That's good. Exit the edge flange. Go ahead and save this as part number. We are at part number 3. SB sink bow, sink bottom, undershelf. Is this the spelling of shelf or it is with an F? I don't know, I will check. Now we have a couple of parts. Let us do the assembly so that we may get the size. We might evaluate the size of the what do we call it, the back panel and also the partitions and the mid shelves and all that. So create new assembly, click OK. Now the first part that we are going to put in is the top, right? And the top, and we shall make sure that the planes of the work area and of the sink, the top, are in agreement. So select the front plane and the front plane, mate them, then the right plane. What's going on here? We are selecting the front plane of the assembly and front plane of the top. Click OK. Then the top plane. What is not happening? Oh, alright, I kind of forgot. We need to first make this float. Right click it and make it to float, so that when you select this plane, that front plane and the front plane of the sink, see the top now is floating and going where it is required. Then the right plane and the right, basically we are just mating all those planes, so that when you are doing the other assemblies, you won't be required to go to the top and start expanding the folders. Now right click and fix the top. That will be the fixed part. Now insert component, insert sink bowl. That's good. Met this part, that top of the sink to bottom of the top. Now you can comfortably select the right plane of the bowl and the right plane of the assembly area. That will be good. You can't go for that because you can't go for this front plane because the cutout is offset from the origin. So you can select this face and this edge here. Yeah, and your assembly is taking shape. Now, for you guys who are in fabrication, fitting the bowl for the purposes of welding, it is always hectic because this part, the bowl at the top is always, it's not rigid, right? It's not rigid. It will hardly be a straight line. So what you normally do is you don't start doing your full welding. First you balance the bowl to the cutout, do tack weld at one corner, then do another tack weld, tack weld, tack weld, then you do tack, close tack welds all around before you do your full welding. Very many people normally encounter all sorts of troubles when they are welding the bowl to the top. If you are not very careful with it, you will start doing some notching, and at the end of the day your bowl won't be neat, it won't be straight. You will have some issues with it. Sorry, we are not mating, we are inserting, and we are going to insert the side panel. Now we met this part. That face will always touch that face, and this face touches this edge here. This face touches this edge here. Yes, that's good. Now for those who was wondering why we were having we were deducting 30 millimeter from the overall size of the undershelf, is because you know, the sink is 1500, and remember we have an edge flange here of 15 millimeter and another edge flange here of 15 millimeter. Same applies to the side. We have 15 millimeter here and we have 15 millimeter here, right? So that you know, your side panel flashes with the back side of the top. Now we can go ahead and insert our undershelf. Undershelf, the side panel, we met the side panel sits on top of the undershelf, and this flashes with this face of the side panel, and this flashes with this. Now you see, everywhere it is flashing. And for this, we don't do a lot of welding, because this is the face. Here you can do a full welding. Remember the undershelf, you will do a welding there. You can do a stitch weld here about 2 inch long, 1 or 2 inch long. Same here, then a small tack weld someplace there. Okay, now in as much as I might want to mirror this a little bit later, let me mirror it at this point. So I will go for the right plane of the assembly and the mirror components, and I select my side panel. Yes. Now, since this sink will be a wall type sink, and the back will always be against the wall, you don't want to have your joint, the joint of the back panel and the side panel, to be at the edge. Yeah, you want it to be hidden behind there, hidden by the wall. That is why we did an edge flange of 100 millimeter here and 100 millimeter, so that the back panel goes right, the joint goes right into the surface that will be against the wall, and nobody will ever see that. Yeah, they will always see a very clean finish from this side, right? So that is why we didn't do an edge flange here of 10 millimeter. And again, also this reduces the size of the material that you are going to be using for the back panel. Hence, you will be saving on materials. Let us evaluate and get the size of the back panel. From that face to this face, we are measuring, and the size should be 1270. So we create the back panel, go to file, a new part, okay, then go to for the front plane, a new sketch, send a rectangle, snap it from the origin. The size is 1670, not 1470. Is it 14 or 13? 1370. No, this is the one which should be 1370 by 650. The height of the body is 650. Go to sheet metal, base flange 1.2 is the thickness of that material. Click OK, then create edge flanges all around, 10 millimeter edge flange all around, right? There you go. This is 10 millimeter. Right click, save it as back panel. Part number 4, SB hyphen, what is wrong with me? SB sync hyphen back panel. I'll go back to the assembly. We can close the top we can close the bowl. We can close the side panel. I shouldn't have closed the side panel, but we can close the undershelf and open the assembly. Actually, before we continue, let us save our assembly and call it single bowl sink. If you want, with body, because we might be having a single bowl somewhere else in our layout. And remember, we said we are going to arrange these items in the layout, and I was thinking we are going to export all these items. We are going to save them in STL so that we may open them in Blender. We want to give the layout a nice render. You know, these are some of the things that will always bring customers your way. If your presentation is awesome, then your clients will definitely want to inquire for your services, right? Now we are mating the back panel to the sink. Here let us do we were not supposed to do that. We could have gone for the planes, but that still, it's okay. You know, I told you it is always good for you to be knowing different ways of doing the same thing, right? Different ways of doing the same thing doesn't hurt. Not the edge, but we want the face. This face will always sit on there. Make it standard, yes. Now you see where your joint will be. I hope we should have given it a 1 millimeter, 2 millimeter allowance so that they may not overlap. So we could have edited it from there, but now that we are here, minus 2 millimeter, 1 millimeter from each side. Yes, we don't want it to be tight. It will start bulging. Did we consider the edge flanges? I think our size is not right. It is 1370, right? $1470. It is 12, not 13, but 12. Because it's 1470 minus 200 minus 30. Now I feel like it should be where it's supposed to be. Yes. Let's see. There is small gap there. 1 millimeter gap on either side. Now there is something else that we normally do here. We normally do a U-channel to hide this joint. So let us create that small part there for hiding that joint. Go for the front plane, new sketch, center rectangle, snap it from the origin. Height is 650, and this we can do 15 mil. Sheet metal base flange, we can do 1.2 millimeter. That's okay. And create edge flanges on these two sides, this side and this side. Remember that joint is 10 millimeter. Okay, the edge flange there is 10 millimeters. For this you can do 12, not 3. 12. Where is the 3 coming from? 12 mil. Right click and save it. Just give these things parts that give these parts names that you can easily remember. SB sink, and I will call it joint hider. It's a name that, you know, don't follow my English, okay? Don't follow my English, especially if you will be sitting for an exam someplace. Let me not make your life hard, right? Now this part sits on top of the undershelf. That's good. Let me first of all exit the mat and hide this. Hide the top. Can even hide the bowl. No, the bowl, no issue. Now let me continue with my matting, and this time round I will choose this. Well, it's a small piece. It's a small work piece that will make a huge difference. Some people might choose to leave it as it is, but trust me, this is a very small. We shouldn't have done that, but hey, it's still okay. It's a small thing that will make a huge difference to the finish of your sink. We are mating with that face to this face here, between the joint, between this and this. Let us see whether it is correct. Yeah. Now, like I'm saying, it's a very small workpiece there, and since here you're going to be having people will be opening the doors, it will be visible, you know. Yeah, just know it is important. Okay, we can we mirror it at this point? Go for the right plane and do mirror. Yes, we can mirror, though there are some few. No. Let's exit that. Even though you can still mirror, and when you want to mirror something else, you will always come back and edit. Make your top visible. Now, we will open this. Yes. Open this and save it as. Save as a new copy and open it. And this part we are going to call it 2A. Part 2A, side panel partition. Side partition. Yes, partition. Right, because we want to edit this part. This edge flange here is the only one. First of all, this, we don't need this edge flange. Which edge one? Yes, we don't need this, so you can delete it. Let us hope there won't be. It's okay, we will still add the edge flanges. This also you edit and make it not 100 but 15 mil. Don't need a huge edge flange. And also the base flange here, the base flange, you can edit the sketch and make it a little bit shorter by 2 millimeter. Remember this, the partition will be inside the back panel, it won't be flashing, so it shouldn't be the same size as the side panel. Okay, so just reduce it with 2 millimeter. The other edge flanges remain and create edge flanges on the top at the bottom. So here we need that edge flange, this direction of 15 millimeter. What's not happening here? First give it size of 15 millimeter. Yes. Yeah, that's good. This work. Yes, that's good. Can we mirror? Yes, we can mirror by selecting the top, then going to feature, layer, we go to mirror entities. And what are we going to mirror here is this edge flange. Click OK. So the edge flange is good. So save that one. Remember, we didn't create a new part, we just edited that part and saved it, right? So go back to the top and do your assembly, and this time you are inserting. Why am I going for mating instead of inserting? We are inserting the side partition. Yes, that is good. Now we do mating, and this face flashes with this. As always, the bottom edge flange will sit on the undershelf. That's good. And you can go for distance and just make sure that the side panel, there is a 10mm gap between the face that face and the face of the bowl. Right. Yes, your partition is good. Exit the mat. Okay, so let us evaluate here and get the dimension of the mid shelf, right? Evaluate, measure. The size will be, normal distance is 472 by, I'm noting somewhere, by from the back to this edge here. Might not be able to see it correctly. Let me hide this. Let me hide the top. Then I measure from here to here. That is by 643. Remember to give it an allowance. Then this panel, this undershelf, mid shelf here, we are going to notch it. So measure from here to here. That should be around 91, and the gap is around 15mm or 20. You don't want to notch it big. 15 notch is 15mm. So yes, we go to file, new part, create new part, and this is the mid shelf. Go to top plane, sketch, center rectangle. We saw that to be 643, 642. Now let us do 641. We'll give it 2mm allowance by 470. We measured 472, so we are giving it a 2mm allowance. Base flange still 1.2 is the thickness of the material. Do edge flange is round. If you want, you can create what do we call it, a mitre joint, a mitre flange, sorry. If you are tired of doing the edge flanges, you can create a sketch and do a miter flange. The size is 30mm. Right click, then yeah, create all edge flanges before you notch. All around 15mm is the end condition, blind 15mm. Right click, then go to the top and create a new sketch here. Corner rectangle, then give it a dimension from this edge to this. We saw it as 90. You can do it at it was 91, so let us do it at 89, and this is 15. You can do it as 16, and from here to here, remember our edge flange for that joint cover was 15, so we do again 16mm. Then go to feature and extruded cut. Just to make sure the size, you can do it at 35 or 40 because you want to cut through all. Yes, that's good. Go ahead and save it as part number 6. SB Sing Mid Shelf. That's good. Go ahead and save it as, and you create 6A and call it mid shelf. Right, this should be for the right side. Sorry, we are not going to mirror this because the cutout, the extrude cut will be on the opposite side, so we are editing that and create a center line here. Right click, select that and mirror it, and mirror about that center line. Right click, select all these and make this construction for construction. Right, exit the sketch. You want the notch to be on the other side, right? That's good. So now you can go back to your assembly and insert component, and the component to insert is them. What happened to the one that we were saving as? It disappeared. We should have we should have mated first, then we insert. It's okay, we are going to go back and redo it. So mate, no, we want to mate, but I still feel like that part should still be there. This face touches on this. There is another notch that we should do there, is it? And this face here touches on this face. Then we go for the, it's not happening here, for this top plane. No, not that plane. Clear. We can go for the side panel. Side panel. Where's the side panel? Sync ball top. Side panel. Yes. Side panel top. And mid shelf top. Yes, we want it to be at the middle. That's good. Let us see whether our notch is situated in its right position. Yes, it is situated in the right position, but it is too big. Can we evaluate and see between this and this? It's about 3 millimeter. So that our notch, we gave it a big notch. Again, you don't want the notch to be that big. I'm wondering why. Let me check again. From here to here, 97. Okay, so let us edit this part. You can edit it from here. Is it so? Yes, we can edit it from there. It's the mid panel, and we go for the extrude cut and edit the sketch. Yes, 97. It was supposed to be 97, so we should have done 96. 96, and this we can do it as a notch of 4 millimeter. When you look at it from here, you still can tell that 4 millimeter is a little bit small. 6. Yes, see, the gap is not big. Exit the edit. No, we shouldn't have exited, because you see the depth, we gave it a big depth. This was 10. So still we edit again and go for the sketch. Edit. We need to edit that sketch. This we gave it 16 millimeter. 16 is way too big. Remember that edge flange there is 10 millimeter, so we can do 11. Even 11 is big. 10. I know why it is appearing to be big, because the 2 millimeter allowance that we gave, we didn't do a width met. Remember, we gave our mid shelf some 2 millimeter allowance. If you can look carefully, you will see there is some bit of a gap here between the back panel and the shelf, which is okay. Just, we don't need tight things. Okay, let me go for that folder and see whether whether we have that part. Projects, layout, single bowl sync with body, mid shelf. We have mid shelf, yeah, it's right there. So here we can insert, assembly, insert, and we will browse and go for the mid shelf. I was telling you, we had saved it. This is good. Now we met these flashes with these. That's good. These and these, they are the same height. Then this face touches the side panel on the left side. That's good. That's perfect. Now we will bring back our top we will unhide the top so that we may create the door, make it visible. We want to create a door. Let us measure the size of the door. The door will be from here to here. We give it 375 by, we give it 2mm allowance from here to here. That is 606. We'll also give it around 3mm. So we go to file, new part, okay, go for the front plane, create new sketch, send a rectangle from the origin. This we saw it is 606, 604, 2mm allowance. No, actually we give it 3mm allowance. You don't want the door touching the edge of the top. By 375, 372 would be good. Sheet metal, base flange, 1.2mm, or you can do 1mm. There is no harm in having a light door, edge flange all around. And that edge flange, remember we have an edge flange there, which is 25mm. 25. Right click, then create an edge flange. Here, of 15mm. Okay, now save it as part number 7. Call it as sink door. Now we need to do a channel here for reinforcing the door. So how will the channel look like? Let us first evaluate, measure and get the size, the height of the channel. Okay, you can take your 372 minus 30. You will get, no, the channel should go inside there. So it's 372, right? But since it's on the inside, it will be slightly less than 372. 600. File, new part, okay. Again, front plane, sketch, center rectangle, height 600. You can put 599. 1mm allowance. This should be 100mm or even 75. Doesn't hurt. Go to sheet metal, base flange. 1.2 again is good. Now create edge flange. Come into this side, this direction, edge flange, and this should be 24, around 20, 23, 24. Click OK, then edge flange going outside. How do you want your channel to be like that or like this? You can do it like this. That is 15mm. It's good. Save as backing, door backing 7A, door backing channel, backing you want to give your door some strength. Okay, now let us go to new, and this time around is sub assembly of the door and the backing. Go for insert door and the backing, insert again, backing channel, door backing channel. That's good. Then do your matting, this face to that face. Then you go for the planes. Right plane, is it right plane? No, not right plane, but top plane and top plane of the backing. That's good. Then front plane. Do I keep confusing this front plane? Right plane? Yes, right plane and right plane. You want your backing channel to be at the middle. Yes, that's good. Now we need to edit this. Edit. Yeah, first we save it as door assembly, door sub assembly. You don't want to write sub as. Remember we had started the editing here. We will go for what? This edge flange here. We are not editing the door. We are editing the backing channel. Yes. Make it 23. It should be 23 point something, point 6. Still not really 22.6. Is it still big? No, that door is pretty much fine. Let me mat again. Let me delete this and do the matting again, because I matted it wrongly. Okay, I could have edited the matting, but since I have deleted, let me re-edit it. And it is this face. This face should be touching that face. What's going on? I did not select that. I'm doing some matting. That face to this face. That's good. Now go for the planes, top plane and top plane. That's good. Then front plane. Why do I keep, seems like I'm in love with front plane. It's right plane and right plane. Yes, my channel is sitting well, sitting pretty. Only about 1 millimeter. Let us edit base flange. We edit this base flange and make it 22. Does 22 seem okay to me? Yes, it is good now. Save all these changes. Save all the changes and go back to the major assembly. We can close the back panel. We don't need it. We can save it. We don't need the joint. We don't need side panel. We don't need side partition. We don't need mid shelf. Save. We need door. We don't need door. We surely don't need the backing. All we need is this door assembly. So we insert, and insert here we do sub-assembly of the door, then mate, and this face will definitely flush with this. Then you can take this, you can give it a 1mm or 2mm from the bottom distance. Make sure it's will always be a gap, you know, you want the door to swing. I'm going to change that because I will change the direction. Now go to advanced mate and choose width, this face and this face. I think the allowance there should have been 5mm. Between the door and the sides, you need to have a 5mm, at least 5mm gap. Now, let me collapse this and go for mates, and this distance here, I edited it. Why are we editing this distance? We need to flip dimension. Yes. Yes. You want your door to be swinging without they have been coming into contact with the undershelf, and there should always be a clearance there. You don't want friction. Let us hide this. No, we can do, let us do one more thing, and that one more thing is create the channel for the legs and the legs themselves, so that when we mirror it once. So we go to file, new part, okay, top plane, new sketch, center rectangle. Sheet metal doesn't involve a lot of things. 670, you can do 668. When you are inserting this channel, don't encounter problems because you did you didn't give allowance. Go for sheet metal, base flange. This should be 1.5. You know, this is carrying weight. That channel should be 1.5mm thick, right? Create edge flange here of, remember our edge flange of the undershelf is 30mm. Do this 28mm. That's good. Then edge flange on this one side only, that should be 15mm. And save it as part number 8, SB sync leg channel. We are good. Before I create the leg, let me get the height so that I may know the height of the leg. So it's from here to there, should be 660. That is 661, and we need it to be 830 because of 30mm grommet. 660, 830 minus 660. So the leg is around 170. So I'll go to file, new part, click OK, top plane, sketch, circle, the origin, diameter. Leg should be 38mm. You can do 50, but 38 will look pretty good. Then offset it by 1.5. That is the thickness of the leg of the circular hollow section, and it is in the reverse direction. Then go to feature, extrude, and blind 170. Your leg is good. Save as part number 9. SB sync leg, not LG, not life is good, it's leg. Now go back to your assembly and insert those two components. Insert the leg channel and the leg. 1, 2. Now mate, definitely this face will be against that, and this face will touch this face here. You can go for planes if you want, you can go for not right plane, front plane of that and front plane of the undershelf. Yes, that's pretty good. Now the leg, this face here touches this face. Now move it appropriately, go for tangent, and this and the edge of the undershelf, make it tangent, right click, also tangent again, and this, that, and this edge here. Yes, that's good. Now remember, your welding will be here and here. This welding is enough here and here. That's good. Now before we continue undershelf, yes, you can go for the front plane of the undershelf and do mirror the leg. Yes, you have your two legs there. Now let us hide the top because we want to mirror a couple of items here. We go for the right plane. Yes, right plane and mirror components. The first component is this, then this, then the two legs. You can choose the first mirror that you just did, or whatever. Choose this, and the channel. Right click. See, this thing is almost done. Bring back the top. How many times are we going to bring back this top? Make it visible. See, your thing is good. Now, let me just complete it, and I'm going to insert. Remember, I had done a grommet. Maybe you didn't see me do the grommet, but I had done a grommet before grommet assembly. Actually, it's like we did some. We shouldn't have mirrored these things before inserting. We should have inserted the grommet, then do our mirror later. Concentric relationship. Let's pull it down, and this part is always hidden in the tube. That's good. Can we see whether we can do our first mirror and edit it? Our mirror component 1. No, that was for the side panel. Mirror component 2. was for the legs. Let us edit it, and we had the grommet. Is it? Yes. We can even edit mirror component 1. Collapse things. Mirror component 1 and edit, because we mirrored it. No. That mirror there will give us problems. Why don't we edit mirror component 2? And we are going to add this grommet and this grommet. Yes. Now, let me open. Do I need to open that door? Now, the part that is remaining here is to bring in the bushes for the doors. I'm pretty sure you can do that, because it's all about fabrication, and you don't need flat pattern for anything. For the bushes, you machine a bush of dia 25. You do 2 bushes here and here, here and here, because the doors are supposed to be swinging like this. Then you do handles, and the handles, please don't weld the handles when you're doing. Let us do one handle. Let us do an handle. Do we need an handle? Let's see whether we will do an handle. Go to right plane, click OK, sketch line, smart dimension, this should be around 50. This should be, you can do an handle of 100 or 75. This should be 30. That's good. This point and this point, make them vertical. Then fillet that sketch and give it a fillet of 8mm, because the handle will be of 8mm. So the fillet should be 4mm. This and this. No. This and that. We have different types of handles. Exit the sketch, because we want to create a sweep. Front plane, new sketch, to the origin circle. Origin diameter is 8mm. Use a rod of 8mm. Or go for we sweep. Then you select this sketch. That's good. The handle is good. Sketch. Shouldn't we have created an hole? Select the 2 circles, hold down the shift key, select the circle and make them equal, and give them a dimension of 4.5mm. I believe that should be the size of the screw, the self-tapping screw that you're going to use there. Is it a self-tapping, or let me just call it a screw? Go for feature and extrude cut. We can extrude it up to 6mm. That's good. I hope I'm going to get the threads correct. They should start from here up to selection. Selection should be that one there. And also we need other it's okay, we'll create metric die, metric tab, metric tab. Is the metric tab going to work? Yes. Repeat the same on this other side. Thread, whole wizard, thread. Here, thread location, you select this point here and you select up to selection here, and it's metric. We normally use metric tab. Yes, because you're doing what? 1.2 point. You know better. The handle comes with a. Now, save. Call it. Part number 10. Let's be saying door handle. Oh, do we have any issues? No, we don't have any issues. Now go back to your assembly and select your door. I'm sure we will have some issues, but we will deal with them perpendicularly. Create a new sketch here and create a hole where you're going to put your select, make them equal, and select this and this, make them vertical, dimension it. This should be 4.5 or even 5. Make it 5. Then from the edge, center to the edge, you can give it 20 mil, and from the top this you can give it 150, and the two centers is 75, right? Sorry, center to center, what's not happening? On center to center is 75. Then go for feature, extruded cut, link to thickness. Link to thickness, that's good. Yes. Save it. Now let us go back to our assembly. Yeah, I told you it will give us all sorts of issues because, you know, remember this door, how it looks like? File. Insert, and we are going to insert the door handle. Door handle. Can we go for concentric relationship? And this is between that. Where is my handle? Clear. Yes, that. I'm not sure whether I did the right selection. And this. yes. Then this and this face. Let's see whether our handle looks good. Yes, was this 100? I think it was 100. So let us edit this, edit, and extrude a cut, edit. We are editing the sketch, and this is the one that we are making 100. The beauty of SolidWorks, right? It was AutoCAD, my friend. AutoCAD, I always equate it with how we used to do our technical drawings at college using set squares and T-squares and HB pencils and protractors, you know, those things, doing the manual kind of drawing. Yeah, but thank God we have softwares right, left and center which help us in our design. I think this handle is okay. This handle is okay. Maybe let me edit the fillet. Okay, the sweep sketch 1. Let us edit it, and we go for this. This we can make it a little bit bigger. Can we make it 20? I don't know whether 20 will work. Yeah, does it look neat? Sort of. Of different types of handles. 20 looks a little bit funny. Maybe I should have done it 8 mil. Yeah, we'll leave it at that. But ideally it should be 4, because that radius should be 4, but that's good. Now our handle looks good. Now, because we did some mirroring, these holes should be on this other side. Okay, so we can delete this. I'm tempted to delete this sub-assembly, and we didn't mirror this. That is which right plane now? Yes. When we were mirroring, we didn't select this. Should have mirrored this. This handle should be on this other side. Let me delete this. Yes. Then I open. This part here. Can I save it all up? Can I save this? Save as a copy and open, and I will save it at sub-assembly 2. Right. Yes. I'm not sure about that. Then there is this extrude and cut. I edit it, and I will go for center line. Then select all these and mirror them. Where is the mirror? Mirror entities, and we mirror them against. Delete. Mirror about this line here. That's okay. then we select them again and make them. What's not happening? We want this construction and this construction. Good. Yes. Yes, now the handle can go in its right place. Save all. Let us hope that we didn't interfere with the opponent's fragment in concentric there. See? That was not. We did it wrongly. We did it wrongly. I don't know. Is it possible to where is the other door? Door until okay. We shall maintain that. Then we'll go and open what are we doing surely? What are we doing? What are we doing here? Let us open this. Why are we not opening this? Open door assembly. We'll go for this and open it. Then we save it as. Oh man. I think my head is tired. You know what I'm trying to do. I'm just trying to bring this what do we call them? I'm trying to align this extruded cut. Door. Okay. Then let me see whether this has changed. Yes. Now I will go for the door assembly, right, and close it. Okay, then I will take this part. What is this? Door assembly, and close it also. Yes. Then I will go for the door. This door, I will save it as and call it right door. Yes, it's door, right side door. Did I open it? Yes. Then I edit this sketch, and these two, I'm going to make them construction. What is not happening here? Oh yes, did I make them construction? Yes. Then I make this them. Yes. Then that being the case, I will just need to go for a new assembly of that door. Assembly, and I will go for the door right and insert channel, insert the channel, insert component, and it's leg channel. Let me browse, go for door channel, door untold, door right, door where is that door backing channel? Here. Then we met this to this. That's good. Let us go for the top and the top. That is good. Then front, not front but right, right and right. That is good. Now this we are going to save as we replace that. Yes. Yes. Good. Let us close. What we don't need closing. So that we don't encounter problems again. Do we need that? How many doors are we having? Surely. Insert component. This. Yes, now I feel like we are there. And net this to this. This face, remember we gave it a 2mm allowance. That face to this face. Then we are going to go for what's not happening here. Advanced met with this face and this face to this face and this face. Mama yangu. No. We're going to edit something there. There's one met here which is not doing us justice. Yes, now that is good. Sometimes when you do these things and you are not very careful, or you want to take some shortcuts, that is when you encounter all these sorts of problems, I'm trying to mirror the handle, see whether it will go. Yes. There we go. No. No. Let's just delete this mirror and insert another handle. Man. Is it that I'm tired or what? Doing my own things here. Where is the door handle? Can anybody see door handle? Door handle. Oh God. Let's just say that I'm tired. So early in the morning. For your information, in my country, we are doing our elections today. Today is the day that we are going to elect that leader that we will be suffering at his hands for the next 5 years. You know what I'm saying? Because our leaders always take us for a ride. They lie to us. You know, one of our leaders was promising us that if we elect them, they are going to bring the World Cup to Kenya. Ain't it funny? Ain't it funny that somebody can make such a promise to bring World Cup to Africa, Kenya, country that has never qualified, a country that hardly qualifies for Africa Cup of Nations, a league with a national league which is not popular to anybody. Then the leader has the audacity of lying to our face that they will bring the World Cup to Kenya. Do we even have the facility to host a World Cup? I don't even think the big clubs can decide to go for to come for their pre-season in our country. Imagine Barcelona playing in Kenya. In which field? Which one? Oh man, these people, they normally see us as fools, but hey, I'm now a politician and I'm not in politics. It's just that sometimes you sit and wonder and try to imagine, what is this fella trying to tell me? Alright? What is he trying to tell me? I don't get it. I really don't. It is so funny. Anyway, so much for that. I want to try and bring in the, what do we call it, a bush. Bushes of dia 20. I'm going to create a plane, then another plane, right plane, and reference plane. What was the size of this door? 375 divided by 2. So this should be 375 divided by 2. Divide over 2. Let me flip direction. Yes. Then I take the top plane, create reference plane, 3606, 606 divided by 2 minus 100. 2 or 3. Yes. file, create new part, create in the bush, guys. Got carried away there by politics, but it is so wrong. It is so wrong for somebody, a leader that bears the title honorable, to stand in front so many people and lie to them, to their face, man. I really don't understand. 8.5. Extrude. This we are going to extrude it up to 20. I really don't get it. Mid plane 20 millimeter. You know, we had another one 5 years ago promised to bring us the Formula One, you know, to create some Formula One stadium field and to bring SB Sync bush, call it a SB Sync bush. You know, Michael Schumacher was supposed to come and do his thing. Does he really still continue with this thing, or is retired? These are our adorable leaders, man. They're so sickening. But it's still okay. We have our lives. It's not like they are going to come and to bring any change, any significant change. Anyway, don't worry about that. It's just by the way. But should any of them find their way into my channel, you know, you leaders, just know that this name that you bear, honorable members of parliament or members, you know, cabinet secretaries and all that, you don't deserve it. Honorable is a derivative of the word honor. It is somebody who commands respect because of his actions, because of how he conducts his business, right? It's not just a title. Just because you've been elected for a position, then you automatically become an honorable member. You bear the name honorable. No, it is your actions, man, which should qualify you to be called an honorable member, or, you know, to be called. Let me leave it. Let us do sub-assembly of the bush. Sometimes I normally get worked up when I hear somebody trying to play with my mind and trying to portray me as a fool, which I clearly know I'm not. But in the real sense, it is them who's supposed to be real fools. Yeah. Yes. And you know, one of the problems with our leaders in Africa, they are so corrupt, and when they go in there, they make sure that their people, their relatives, are the ones who are getting. Hey guys, let us get back to work, right? So much for politics. I'm trying to close what I don't need. You know, I'm not not used to working with you know, once I'm done with a part, I like it closed. Right, and now we insert, and we are going to insert the bush assembly. I created some planes someplace because I intend to use them in the assembly. I don't know, make this a little bit big. Go for the door. Not door handle, sink, mid shelf. Where is the door? Sink door handle, sink leg. I'm looking for this door, right? Is it the one? Yes, plane one. That plane one, let me match it with the right plane of the bush, not bush assembly, but bush A. So it is that right plane and this right plane. That's good. Then I will go for front plane and go for, I think this should be plane number 2. Where is it? I thought I expanded it. Plane number 2. I met it with bush front plane. Yes. Then I go to plane number 3. Plane number 3, I met it with top plane, with this top plane. Yes. Then I will go for the top plane of the door and do mirror component. Mirror component and component to mirror here is this bush. That's good. Then I hope, yeah, this mirror should work. This mirror should work. Let me mirror that. You realize you can go back and edit some mirrors there instead of adding more mirrors and more mirrors everywhere. I need to edit something here. This what plane, that plane, I edit it, and this plus 10 plus 10, is it plus 10? Yes. Why is it not working? Guys, let me leave it at that. Ideally the bush should be in between this side panel and the door, right? That is what I've been trying to edit the planes so that I may push it. It's not updating, don't know why, and I have edited the plane. I don't know why it's not working. Can I re-edit it? +5, +5. It should be working. It should be updating because the bushes, yes, see there, that is what I was trying to do. Now your door is good. I should have when I was assembling the door, I should have considered this, so that, you know, and instead of doing this door flashing with this, so that we may swing it a little bit. But ideally that is how your sync with the body looks like. I think everything is there, nothing should be remaining. The final thing is that let us evaluate, let us measure, measure from this top here to the bottom is around 300 right? And the 300, let us open the back panel. This back panel here, we create new sketch and we create an opening of 2 inch. It shouldn't be at the center. Somewhere here, dimension it at 352 for the drainage. You know, don't want to have issues here. From the top is 300 plus around 150, that should be 450. This you need to confirm with the size of your bottle trap. Yeah, this and this, we make them vertical, then you extrude and cut. That is where you are going to link to thickness. That is for the outlet of the waste pipe. See, the sink has body, so you need to provide a hole. Once you have done your plumbing, you know, outlet for the outlet pipe, you need to confirm that height, the height of the bottle trap. Yeah, some of these don't punch holes before you confirm. You might find that the outlet, your bottle trap is either bigger than 150 or smaller than 150, and this hole becomes useless. Also, before you punch holes, before you do holes, if you're using CNC, you know, I know the guys that don't have CNC, they normally do these holes manually and they do them later after they have done the assembly. But if you are using CNC and you want, when you are feeding the program to the machine, you want to cut this hole as you cut the other parts, please make sure you confirm these heights, right? And also confirm the handle that you're going to be using, the diameter of the screw that you intend to use. I strongly advise, don't weld, don't do a weld here. You know, some people can take this handle and do welding. It will look ugly. Just do a, you know, some nice tap thread there, then your screw. Do it from the inside. Anything else to be mentioned from here? No. Now, remember, if I can make this transparent, the edge of the mid shelf acts as the stopper for the door. If you want, you can also provide a lock for your door. You have different types of locks. That is up to you. So with all that, I think we have come to the end of the tutorial. Thanks so much for your time. We will see you in our next video.